Okay, hello guys. Our session for today is asynchronous, no? So, bale, papanoorin nyo muna tong video na to because we will not be able to meet later. Okay? Anyway, so before we proceed with the next topic, sagutan muna natin yung iniwan nating items last time, no? So for this item, we are asked to balance the following equation. Iron 2 plus reacting with permanganate ion, producing iron 3 plus and manganese 2 plus ion. Okay? So, mabilisan na lang to kasi alam nyo na yung steps eh. Okay, so ano unang gagawin? Paghiwalayin yung equation into two half equations. So, the first equation will be Fe2 plus producing Fe3 plus. And then we have the other equation MnO4 minus producing Mn2 plus. Okay. And then after that, let's balance each equations. Okay. So for the equation at the top, tig-isang iron lang yan. So the atoms are already balanced. However, yung charges nila ay hindi balanced, no? So on the left side, you have a positive 2 charge here. On the right side, you have a positive 3 charge there. Okay. So ibig sabihin yan, we're going to add electron dun sa positive 3 so that the overall charge on that side will be equal now to the charge of the left side. Okay. So magdadagdag ako ng isang electron dito. Okay. So ganito na lang. Yan. So that mag-balance yung charges ng sides ng equation na yan. Okay. So, okay na tayo sa top equation. And since the electron is in the product side, we can say that this is an oxidation reaction. Okay. So, punta tayo sa baba. So, sa baba, we have permanganate ion producing Mn2 plus after the redox reaction. So, balance mo muna yung manganese atom. So, tig-isang Mn yan. So, that's good. Ang problema natin is yung oxygen. So, may apat na oxygen sa left side. Sa right side, wala. So, in order to balance oxygen, we have to add 4 H2O molecules on the right side. After nyan, we add 8 hydronium ions, 8H plus, okay, on the left side para mag-balance yung hydrogen. Okay? Then, what's next? Balance na yung atoms niyan. Okay? So, 8 hydrogen on both sides, isang manganese, and 4 na oxygen on both sides. Okay? Okay, so ngayon, let's check yung charge, no? So, on the left side, we have 8 times positive 1 plus 1 times negative 1. So, that will be 7 positive. Okay? On the right side, we have positive 2. Isa lang yan, times 1. Plus 4 na water times there's no charge for water. So, positive 2 yung charge ng right side. Okay, so since mas matalas yung left equation, yung left side ng equation, we're going to add electrons there, no? So, ilang electrons kailangan idagdag doon? 5. Okay, so we need 5 electrons to balance the equation, to balance the charges, no? So, we add 5 electrons here. Okay. And since the electron is on the left side of the equation, we will call this a reduction reaction or reduction reaction. Okay? So, yan. Balance na natin yung dalawang half equations. The final step is to combine them. However, before you combine them, make sure that the electrons are balanced. Okay? So on the top equation, on the oxidation equation, we have 1 electron only. On the bottom equation, the reduction equation, we have 5 electrons there. So that means we have to multiply the top equation by 5 so that the electrons will be balanced. Okay? So times 5 mo lahat yan. Then finally, since balanced na yung electrons, we can combine them to form the final equation. 5 electron, 8H plus, MnO4 minus 5Fe2 plus. On the product side, we have 5Fe3 plus, Mn2 plus, and 4H2O plus 5 electron. Okay, since we have the same number of electrons on both sides of the equation, we can simply cancel them out. Okay, So the balance equation will be 8H plus MnO4 minus plus 5Fe2 producing 5Fe3 plus Mn2 plus 4H2O. Yan yung balance equation. Proceed tayo sa next one. Mabilis lang to ha. Asynchronous naman, so pwede nyo balikan. Okay. So, next one, we have the tin plus nitrate ion producing tin 2 oxide, tin 4 oxide, and nitrogen dioxide. Okay. So, let's balance this equation. Again, you separate the two equations. Separate mo yung tin. Then, separate mo yung nitrate ion. Let's balance yung top equation. So on the top equation, we have Sn and isa ding Sn. So balance na yung Sn. Ang hindi balance sa top equation ay yung oxygen. So dalawa yung oxygen sa right side, wala sa left side. So we need to add 2 H2O molecules on the left side. So balance na yung tin, balance na yung oxygen. Ang ibabalance na susunod ay yung hydrogen. So there are 4 hydrogens on the left side. So that means we have to add 4H plus on the product side. Then after nyan, you balance the charges. No? Balance na yung atoms eh. On the left side, wala tayong charges. So 0 yan. On the right side, we have positive 4 na charge. No? So ito yan. 4 times positive 1. So positive 4 na charge yan. So ang gagawin natin, we will add electrons to that side sa positive 4 so that it will be brought down to 0. So they will equal. No? They will be equal in terms of the charge. Okay. So let's add 4 electrons here. Okay. Ayan. Then okay na tayo sa top equation. Since the electron on the top equation is on the right side, yan ay oxidation equation or oxidation reaction. On the bottom equation, we have NO3 minus producing NO2. Okay, so yung nitrogen, balance na yan, tigisang nitrogen. Oxygen, may tatlo sa left side, sa right side, isa lang. So that means we have to add water. Okay, then may dalawang hydrogen sa right side, sa left side wala. We add 2H plus. Okay. After that, let's check the charges. No? So on the left side, we have 2 times positive 1 plus 1 times negative 1. So that is equal to positive 1. On the right side, we have no charge. No charge species. So that means sa left side, tayo ay maglalagay ng electron. Okay. So isang electron lang kailangan sa left side. Red pala yung gamit ko. Okay. So yeah. So since the electron is on the left side, that is a reduction reaction. Okay. So what's next? No? So what's next is that we combine the two equations. No? Since yung top equation, it has 4 electrons. The bottom equation has only 1 electron. So kailangan natin i-multiply yung bottom equation by 4. No? So multiply natin yun by 4. So that's 2 times 4. That will be 8. Magiging 4, 4, and 4. Okay? And then, yan. So, since balance na yung ating electrons, we can add the two equations na. Okay? So, we have 4 electrons, 8H plus, 2H2O, Sn, 4NO3 minus. On the right side, we have SnO2, 4H plus, 4NO2, 4H2O, and 4 electrons. Okay. Then what's next? No? So we will cancel the similar terms. So electrons will be cancelled out. Okay. Ano pa yung similar? Hydrogen. No? So on the right side, we have 4 hydrogens. On the left side, we have 8. So we have excess of 4 electrons. Okay. So yung water din. So yung water, dalawa sa kabila. apat sa right side. So may excess na 2 sa kabila, no? Ayan, so wala nang similar na. So the final equation will be 4H plus Sn plus 4NO3 minus, producing SnO2, 4NO2, 2H2O. Okay, so that will be the final equation in acidic media. If you want to get the basic media, then add lang kayo ng OH dyan. Okay. By the way, may tip ako sa inyo. Tignan nyo. Yung water and yung H plus, nasa opposite side sila parate, no? So, for example, dito sa equation na to, nasa left side yung H plus, nasa right side yung H2O. Okay? So, ganun talaga. So, always nasa opposite side sila. Kapag yan nagkaparehas ng side, siguro may mali sa nagawa mo. So, ulit ka na lang ulit. Okay? So, tignan nyo to. Nasa left side yung H plus, nasa right side yung H2O. So, always magkasaliwaan sila, no? There must be always in the opposite direction. Yung isa nasa left, isa nasa right, or vice versa. Hindi pwedeng pareha sila nandun sa side na yun. So, yun yung technique na na-develop ko, no? Nung inaaral ko to. Okay, so let's have number 4, write the balanced equation. So we have zinc plus nitrate ion producing zinc 2 plus and ammonium ion. So again, split the equation into 2. Zinc producing zinc 2 plus. We have nitrate ion NO3 minus producing NH4 ion, ammonium ion. Okay. Let's balance the top equation. So the atoms are already balanced. May tig-isang zinc na doon. So yung charges na lang yung hindi pa balance. So let's add 2 electrons there. Okay. Balance na yung top equation. So since the electron is on the right side, that is an oxidation equation or oxidation reaction. So, punta naman tayo sa babang equation. On the bottom equation, we have NO3 minus producing NH4 plus. O kunwari, ganito yung case. Sino yung uunahin ko i-balance? Is it the H2O? Is it the oxygen or the hydrogen or the H plus? No? So, pag ganito yung case ng problem ninyo, you should balance the oxygens first. Kasi yung hydrogen, madali na lang i-balance yun mag-isa. Kasi H plus lang idadagdag mo eh. Unlike kapag oxygen, H2O pa. No? Mag-a-adjust ka pa uli ng H. No? Okay? So, kapag ganyan yung case nyo, pag di nyo alam kung H ba or OH yung ibabalance nyo, unahin nyo yung oxygen. Okay? Last always ang hydrogen. Okay? So, yan. So, let's balance this. Oxygen muna. So, may tatlong oxygen sa left side. Sa right side, wala. So, 3H2O. Okay? Balance na yung oxygen natin. Then, hydrogen na lang, no? So, on the right side, we have 4 hydrogens plus 3 times 2. So, ilan to? 6 plus 4, 10 hydrogens, no? So, that means we should add 10H plus on the left side. Okay? Again, you should count all the hydrogen atoms here. Count nyo lahat yan para hindi kayo magkamali. Okay, so baka kasi ito lang bilangin nyo or ito lang kasama lang dalawa. Basta may hydrogen magkasama yan. Okay. So, yan. So we are able to balance all the atoms. 10 hydrogen, isang nitrogen, and 3 oxygen. So let's now balance the charges. On the left side, we have 10 times positive 1 plus 1 times negative 1. So this will be equal to positive 9. On the right side, we have positive 1 charge only. H2O doesn't have any charges. So that means we have to add 8 electrons, no, for this equation para mag-balance yung charges nila. Okay? So what's next? No? So we will combine the two equations. By the way, this is a reduction equation. So what's next is that we will combine them. Okay, before you combine them, make sure that the coefficients of the electrons are the same, no? So 8 electrons sa baba, dalawa sa taas. So that means we multiply the top equation by 4. So 4, 4, and then ito ay 4. Okay. So magiging 8 na yan. Kasi 2 times 4 is 8, di ba? Okay. So with that, we can now combine all the species there. Pag-add na natin sila, 8 electron, 10 H plus, NO3 minus, 4 zinc. Then on the right side, we have 4 zinc 2 plus, NH4 plus, 3 H2O, and 8 electron. Okay, so again, electrons can be cancelled out. And there are no other similar terms here. So this is our final equation. I'm going to remove electrons. Okay, so this will be our final equation. Then H plus 1 mole of nitrate ion plus zinc, 4 moles of zinc metal producing 4 moles of zinc 2 plus ammonium ion plus 3H2O. Okay, so yan yung sagot dyan. So now let's proceed with the main topic talaga sa electrochem na. The main topic in electrochem is the batteries. So how do we produce electricity out of the redox reaction? No? Okay. So dalawa kasing uri ng bagay na pwede mo magawa with electrochem. No? Pwede ka gumawa ng electrochemical cell. Okay. Pwede ka gumawa ng electrochemical cell. Wait lang. And so, pwede ka gumawa ng electrochemical cell o kaya pwede ka gumawa ng um, lang. Okay, so may nakalimutan lang kasi akin. Okay, so yung electrochemical cell, dalawang uri yan. Yun yung hindi ko mahila sa dila ko. Okay. So in the electrochemical cell, that is a cell composed of electrodes and the solution which either uses or generate electric current. No? So dalawang uri yan. Meron tayong voltaic cell or galvanic cell. That is a cell or electrochemical cell which produces electricity because of the spontaneous reaction. Okay. So, ibig sabihin, ito yung ginagamit natin sa batteries natin. No? Okay. Yung isa naman is electrolytic cell. So, what is an electrolytic cell? This is a type of cell that uses electricity no, in order to drive a non-spontaneous reaction. So, saan to ginagamit? No? So, ginagamit yung electrolytic cell sa copper plating, gold plating. No? So, kunwari may jewelry ka, gusto mo lagyan yun ng gold. No? So, pag nilublob mo yun sa gold, di naman agad kakabit yung gold doon unless kuryentehin mo sila. Okay. So, yung pagkuryente mo ng gold solution para dumikit yung gold doon sa jewelry, that's a form of electrolytic cell. Okay. So, again, ano yung dalawang types ng electrochemical cell? One is the voltaic or galvanic cell. The other is the electrolytic cell. So, yung voltaic cell, this is a cell or electrochemical cell that produces electricity because of the spontaneous reaction. Okay. However, electrolytic cell, ito yung type of electrochemical cell that uses uses electricity to drive off non-spontaneous reactions. Okay. So, punta muna tayo sa voltaic cell kasi ito yung medyo mahaba topic na. So, yung batteries natin, that is a simplified version of voltaic cell. Pero before the creation of our modern batteries, ganito yung umpisa. Ganito yung itsura ng battery before. Okay. So you have two solutions, no? The one contains a metal solution and an electrode. The other one contains the same, no? So may metal solution doon and may electrode, no? And in between them, you have your salt bridge, no? So again, ano meron dito? So ito yung voltaic cell. Meron kang metal solution, okay? May metal solutions ka dyan. metal solution ka, and then you have your electrodes. And in between them, you have your salt bridge. Okay. So, yan. So, ano yung purpose ng metal and the electrodes? No? Ang purpose ng metal and the electrodes is to allow the redox reaction to happen. Okay? So, i-allow niya yung redox reaction dyan to happen. No? So, kuha tayong example dito sa sinagutan natin. Okay, so for example, ito. Paano yung zinc? Magiging zinc 2+. So, may zinc electrode doon na nakalublob in which yung zinc magiging ions. No? So, yun. For example, ito pala na. Ito na sa picture. So, kunwari, itong zinc na to, pwede yung maging ions, no? And it will give off electron. So, mag-undergo yan ng oxidation reaction. So, yun yung purpose ng metal solution and the electrode, no? To allow the conversion of your chemical species as it undergoes redox reaction. No? So, for zinc, for example, metal yan, magiging ion, it will give off electron. Okay. So, saan mapupunta yung electron? Dadalo yan sa circuit. So, may bakal dito that is connected to the other electrode which will accept the electron. Okay? So, dito naman sa side na to, what happens here is that the solution will accept the electrons so that the metals in the solution will be deposited in the electrode. No? So, yung metal na nakahalo sa solution nyo ay kakabit sa inyong electrodes. No? Okay, so ganun. Yan yung itsura ng voltaic cell. Pero yung mga nasa batteries natin, mas simplified yun. No? Mas kinompress nila kasi imagine yung magdala kayo ng battery, ganyan yung itsura. No? Pangit yun. No? Pero ganito yung konsepto niya. Okay. So, the usual construction of voltaic cell ay ganito. May notation na sinusunod dito. On the left side, you have your anode. On the right side, you have your cathode. Okay? And in between them is yung salt bridge, okay? Or SB. So, yan. Typically, our anode reaction nasa left side yan. Yung cathode reaction nasa right side. Anong reaction yung nangyayari sa anode, no? Ang nangyayari sa anode is that dito nangyayari yung oxidation. Okay? That's why nililabel natin kung sino yung oxidation, sino yung reduction. No? So, kung sino yung half equation na oxidation, siya yung nasa left side ng voltaic cell. Then, yung kung sino yung reduction, siya yung nasa right side. No? Doon siya sa cathode. Okay? So, ano pala yung purpose ng salt bridge? No? Na-skip ko siya. So, the purpose of salt bridge is just to maintain electrical neutrality. No? So, para balance yung charges. Okay. So, that is, hindi siya magpa-participate sa sa pagbigay ng electrons. No? Ang ginagawa niya lang is to maintain the positive and the negative charges even. Okay? Kasi kung walang salt bridge, hindi gagana yung cell na yan. Okay? Kailangan meron yan salt bridge. Ano yung nilalagay dito sa salt bridge? Usually asin lang, kaya nga salt bridge. No? Gumawa ako nito before. No? So, ang salt bridge ay gawa lang yan sa gelatin na may asin. Okay? Tapos, pag nilublob mo yan dito sa solution, it will allow the redox reaction to occur. Okay? So, ayan. So, dito na naman yung definition. So, you may want to read them. Okay? So, again, sabi ko nga sa inyo, ang anode, doon nangyayari yung oxidation, reaction, and yung reduction ay nangyayari sa cathode, no? So, may mnemonic device na naman tayo dyan. Tawag ko dyan ay oxan red cat, no? Oxan red cat. Oxan, meaning oxidation anode. Red cat, pulang pusa, is reduction sa cathode. Okay? So, yan. So, oxan red cat. So, yung image dito daw sa taas, that is characterized by the two equations. Okay, so ang nangyayari daw sa left side ng dito sa left side ng solution is yung oxidation wherein zinc loses electron to produce zinc 2+ ions. Then, ang lost electron, dadalo yun sa circuit, dadalo yun sa bakal until it reaches the cathode electrode, no? So, pagdating sa cathode, mangyayari doon yung copper ions, tatanggapin yung electron para maging solid copper sila. Okay? So, ano mangyayari? So since itong nasa left side, ito ay nag-undergo ng oxidation reaction, ibig sabihin yung metal niyan, natutunaw siya literally, no? So matutunaw yan literally. So, yan. Tunaw siya because the metal turns into ions eh. So matutunaw yan. Then yung sa right side, what happens there is that yung ions mo nagiging metal. So what happens to the electrode is that bibigat yan. Kasi nade-deposit yung ions into metal. Okay? So yan. Okay. So yan. Ito pa ba isang itsura nun. Okay. So again, ito yung zinc solution. Ito yung zinc solution, zinc electrode. It will undergo oxidation reaction at the anode. Then on the right side, dun mangyayari yung reduction reaction wherein the copper will be deposited as metal sa electrode nyo. And para mag-continue yung redox reaction, kailangan gumawa ka ng circuit, no? Para yung electrons dumaloy. And as a result, may kuryente. Okay? So, ayan. Ano gagawa tayo ng voltaic cell, no? So, bigyan ko kayo ilang examples here. Okay. So, number 1, a voltaic cell is constructed from a half cell in which the cadmium rod dips into a solution of cadmium nitrate. Okay, and another half cell in which a silver rod dips into a solution of silver nitrate. Okay, the two half cells are connected by a salt bridge. A silver ion is reduced during the operation of the voltaic cell. Draw a sketch of the cell, label the anode, the cathode, showing the corresponding half reaction at these electrodes. Indicate the electron flow, the signs of the electrodes, and the direction of cation migration in the half cell. Okay. Ang daming sinabi, no? Pero ganito lang gagawin dyan. So, sabi dyan, dinescribe niya ano yung nangyayari sa ating voltaic cell. So, sa first part ng ating paragraph, no? Sabi doon, may cadmium rod daw tayo. Okay, so may cadmium wrap. Ibig sabihin nun, cadmium metal na nakalublob sa cadmium nitrate. Okay? Okay, so ibig sabihin yan, may cadmium metal and may cadmium nitrate. Ang focus natin dun sa cadmium nitrate is yung cation natin, yung metal ion. So, anong metal ion yung makukuha natin from cadmium nitrate? Okay? That will be CD2+, cadmium 2+. Okay? Okay, paano yun nangyari? Di ba, naalala nyo pa ba yung Gen Chem nyo? So, sa Gen Chem nyo, di ba, pag gumagawa tayo ng ionic formula, nag-criss-cross tayo. So, we want to do the reverse kung gusto mo malaman yung ions mo. So, itong 2, saan galing yan? Kay cadmium. So, 2+ yon. Yung 1 dito, saan galing yan? Kay nitrate. No? So, ibig sabihin yan, ang ions natin sa cadmium nitrate ay cadmium 2+ and nitrate ion. Okay? Gen Chem yan, ha? Alam nyo na dapat yan. Okay. So, ito yung isang half equation natin. Yung cadmium, pati cadmium nitrate, no? Or cadmium 2+, no? Tapos, ano pa yung isang cell daw? May silver daw tayo, silver rod, okay? Na nakadip sa silver nitrate. Okay, so again, silver nitrate yan. Ano charge ng silver ion dyan? Positive 1. Okay. So, the two half cells are connected by a salt bridge, okay, as usual, and silver ion is reduced during the operation of the voltaic cell. So, ito daw yung reduce. So, ibig sabihin yan, ang cadmium ay oxidized. If we are going to create a voltaic diagram or voltaic cell diagram here, ano gagawin natin? So, since alam mo, yung isa ay reduced, yung isa ay oxidized, ang gagawin niya. So, yung meaning nun, yung oxidized, siya ay nasa anode. Siya ay nasa left side. yung na-reduce siya yung nasa right side, no? So, yun yung cathode natin. Okay? So, paano tayo mag-sketch ng diagram? Madali lang. Gawa ka ng dalawang beakers. Okay? On the left side, you have your anode. Lagyan mo ng label para di ka malito. On the right side, you have your cathode. And then, in the middle, you have your salt bridge. Yung salt bridge, ganito talaga itsura nyo. Nakapa-YouTube yun eh. Pero, for the simplicity of our activity, ganito na lang. Ayun na yung salt bridge. Okay. So, actually, may mnemonic ako dito para hindi nyo makalimutan sino yung nasa left, sino yung nasa right. Ganito lang yan. A, B, C. Anode, bridge, cathode. Diba? A, B, C. So, yan. Ibig sabihin, left yung anode, B sa gitna, yung bridge, then sa right side, yung cathode. Daming mnemonics, di ba? Kaya masaya. Kaya nag-enjoy ako sa topic na to eh. Okay? So, you have your salt bridge here. Okay. Ayan natin yung picture. Lakihan para mas makita. Yan. Hindi naman necessary maganda dapat yung drawing nyo. Okay na yan. Okay. What happened? Okay, so yan. Yun. Anode, cathode. Okay, so yan. So what else do we know? Kailangan may metals kayo, syempre. So magdodraw ako ng metal na electrode. Teka lang, lobat. So let me draw a metal electrode. Gawin ko na lang siyang highlighter. Okay. So itong yellow, ito yung ating electrode sa left side. Sa right side, gawin na lang natin green. Okay. Okay. So, yan. So, yan yung ating electrodes, no? And then, yung electrodes, pag dudugtungin mo yan, syempre, naka-circuit yan. Gawin na lang natin, lagyan natin ng bumbilya sa gitna, no? Kunwari, bumbilya. Okay. Pangit ng bumbilya. Okay. Umiilaw yan, syempre. Literal na iilaw yan, no? Nung ginawa namin to sa lab dati, umilaw yung bumbilya. Okay? So, syempre, may solution ka. Lagyan mo ng water. Okay? Water. Okay? So, yan yung itsura ng ating voltaic cell. Okay? So, ano yung nasa left side? Cadmium. Okay? So, gagawin nyo, yung nasa liquid, CD2+, isusulat nyo dyan. Okay? Then, yung nasa metal, yung nasa strip, yun yung CD lang. Okay? So, CD, cadmium. Ganon din sa right side, no? Yung ion nasa liquid part. And then yung metal, edi yung nasa metal part natin. Then ano yung sabi dyan? Sabi, ipakita daw yung flow ng electrons. Paano nagfo-flow yung electron? Saan siya lalabas? Sa anode, di ba? Yung oxidation, maglo-lose ng electron yun eh. So that means the electron will flow from left to right. Okay? So the electron will flow from anode to cathode, no? So drawing ko yan as electron going to the right side. So that is the flow of electron. It will be released from this side going to the right side, no, to the cathode. Ano sumunod? Sabi, ipakita daw natin yung migration ng ions. Okay. So pag sinabing migration of ions, ano lang yan? Ipakita mo kung saan papunta yung ions, no? From metal to liquid ba or liquid to metal, no? So kapag oxidation yan, Since ang metal mo, it will lose electrons, then yun ay from metal to liquid, no? So, ito yung itsura ng migration of ions natin from metal to liquid. Kasi oxidation eh. Di ba kapag nag-lose ng electrons, nagiging ions. Okay, so yan. Kaya ganyan yung arrow dyan. Doon naman sa right side, reduction to. So, from ions, magiging metal. Okay? So, that is from solution to metal. So, yan yung flow ng electrons. Okay? Then, ano pa yung hinihingi sa atin dito sa problem na to? Yung half equations. Okay? So, half equation yan. So, for the anode, so what happens here is that yung CD, nagiging CD2+. Okay? So, from this, nagiging CD2+. So, we can convert this drawing into an equation. So, from CD going to CD2+. And then, ganun din gagawin nito sa right side, no? So, from AG going to AG+. From AG plus going to AG. So, ito yung half equations natin. So, from CD to CD2+, AG plus to AG plus, no? So, yun yung half equations at the anode and the cathode. Okay. So, what if hinahanap yung overall equation? So, if you are asked about the overall equation, madali na lang yan. Marunong na kayo mag-balance eh. So, anong gagawin nyo? Diba half equations to? Pagsamahin mo lang. Okay? So, CD to CD2 plus, then AG plus to AG. Okay? So, yung cadmium, i-balance mo na yung atom. Balance na yan. Charges na lang ang hindi balance. So, plus 2 electrons sa right side. Yung silver, hindi yan balance yung atoms, pero yung charges, hindi. So, plus electron dyan. Then, before mo pagsamahin yan, ibabalance mo yung electrons. No? So, 2, 2, and 2. Okay? So, we combine both equations. So, our overall equation for this voltaic cell will be CD plus 2AG plus 2AG plus 2AG producing 2AG plus CD 2 plus. So, that will be our final equation. Okay. So, that's how you draw a voltaic cell. Again, panoorin nyo na lang ito ulit, no? Para ma-check nyo kung clear. No? Okay, so yan. So again, paano tayo gagawa ng voltaic cell? You draw two beakers. In between, nandun yung salt bridge. O, tandaan, ABC, anode, bridge, cathode. Okay, so on the left side, dun mo ilalagay yung oxidation reaction. On the right side, dun mo ilalagay yung reduction reaction. So, ABC. Okay. What's next, no? Yun. Pag oxidation yan, ang flow ng atoms mo ay from metal to solution. Okay? So again, from metal to solution kapag oxidation. Kapag kapag reduction, yan ay from solution to metal. Okay? So, yun lang. Again, yung flow ng electron naman, ang flow ng electron ay from oxidation to reduction. No? Kasi yung oxidation, it will lose electrons. Saan mapupunta yung electron nun? Papunta sa kabila, sa cathode. Okay? So, yan. So, meron tayong notation for the voltaic cell. By the way, sagutan nyo yung dalawang to, ha? Kayo na magsagot niyan. Ulitin nyo na lang yung video. Meron naman tayong mga notation for voltaic cell, no? Pag sinabing notation, instead of writing the entire equation, ipapakita mo na lang yung ions na nag-oxidize and nare-reduce, no? Okay? So, paano yung itsura ng notation na yan? Okay, so ganito yan. Ang format ng notation natin will be anode. As may double line sa gitna, then cathode. Okay? So, ano meaning ng double line? bridge yan. Okay, so salt bridge yan actually. So, parang yung drawing lang din, di ba? So, ayan. So, anode, ito yung double line, then cathode. Okay, so ganito yung itsura ng ating notation. Okay, so anode, double line, cathode. Okay, so for the anode, may notation yan. Okay, so paano may susulat yung ions mo sa anode? Ganito. So, ganito yung itsura ng sa anode. So, metal, then single line, metal ion, double line na, then metal ion, then metal. Okay? So, yan yung itsura. No? So, yung anode part dito ay ito, metal to metal ion. Yung cathode part ay ito, metal ion to metal. Okay? So, kung titignan nyo yung previous example natin, ano yung anode doon? Yung zinc, ay yung cadmium, di ba? Tignan nyo yung paano natin sinulat yung arrow doon. So, from CD to CD2+. So, itong arrow na to, gagawin mo lang yan single line na vertical. So, paano yon? So, pwede mo yun isulat as CD, single line, CD2+. Okay? So, yan yung shortcut, no? Shorthand notation. No? So, instead na i-drawing mo yan, pwedeng ganito na lang. CD, single line, CD, 2+. Ibig sabihin yan, yan yung nangyayari sa anode nyo. Okay? So, yan yun. Yan yung andito. Metal, single line, metal ion, anode yan. Okay? So, sa cathode, tignan nyo anong meron. Metal ion, single line, metal. Okay? So, tignan nyo yung ating previous example dito. Metal ion, single line, metal. Okay? So, you can rewrite that as metal ion, single line, metal. Okay? So, instead na mag-drawing ka na itong illustration na yan, you can represent this entire diagram with lines lang, vertical lines na lang. So, instead na i-drawing mo yan ng bonggang-bongga na ganyan, na isusulat mo na lang yung single lines, no? Para hindi sayang yung ink. Okay? So, tawag namin dito ay cell notation. So, on the cell notation, the anode and the cathode are separated by two vertical lines. Two vertical lines represent the salt bridge. No? So in writing your anode, that will be metal, vertical line, metal ion. Then in writing your cathode, that will be metal ion, vertical line, metal. Okay? So for example, ito. So zinc, single line, zinc 2+. So since nasa left yan, this will be your anode. That's ito. Double line, yan ay salt bridge. Then on the right side, you have your cathode. Okay? So from this cell notation, you can actually convert your cell notation into equations. No? Pwede mo siya convert into equations. Okay? So paano yan? For this particular example, ganito lang ginagawa ko dyan. No? If you want to convert your cell notation into an equation, what you're going to do is ganito. Lagyan mo ng dalawang arrow. No? Yung mga single line, gawin nyo siyang arrow. Okay? So that means you have zinc going to zinc 2+, and then you have copper 2+, going to copper. Then you combine those now. So ito na yung anode half equation, ito na yung cathode half equation. Pag-combine mo na lang sila. Okay? So yun yung yun yung purpose ng cell diagram, no, or cell notation pala. So on cell notation, pwedeng ito yung shortcut ng drawing mo. So, ibig sabihin yan, ito yung anode, ito yung cathode, ito yung salt bridge. Okay? So, ito yung mga electrodes mo, copper and zinc. Yan yung electrodes mo. And from this, you can convert them into equations. No? So, ano gagawin nyo lang, yung single line, lagyan nyo lang ng arrow. Okay? So, itong nasa left side, itong equation na yan, that is your anode or your oxidation reaction. On the right side, your cathode reaction or your reduction reaction. Okay? However, however, sometimes kailangan natin ng catalyst, no? Especially kapag yan ay hydrogen gas. Minsan kasi hydrogen gas yung kailangan sa redox reaction para mangyari yan, eh. So, if ever ikaw ay kailangan mo ng hydrogen gas, okay, so for example, ito yung sa cathode niya. So, H plus, ion, ito, H2, gas nga lang to, hindi siya metal, pero parang ganun na rin. Then, after nun, naglalagay tayo ng PT, no? So, what is PT? This is platinum. Yung catalyst, sa dulo parati nilalagay yan, no? Either sa dulong left or sa dulong right, no? So yung catalyst, they are not used in the electrochemical equations, no? So hindi sila ginagamit for electrochemical equation. Andyan lang talaga sila to help the reaction to proceed, no? So hindi pwedeng ganito lang, no? H plus then H2. Okay, kasi gas tong H2, eh. So kailangan yan ng catalyst. So susulat mo sa dulo yung metal, no? Usually platinum yan. Okay. Pwedeng nasa dulong right, pwedeng nasa dulong left. Okay. By the way, kapag magsusulat tayo ng notation, kunwari may mga coefficient ka, hindi mo isusulat siya dito. Okay? So may coefficients ka ng equation, huwag mo siya isusulat. Okay? And then sometimes we also indicate the concentrations just to be specific, no? Especially for ions. Concentration and pressure, just in case na kailangan. So let me try some, no? So number 1, write the notation for a cell in which the electrode reactions are. Ibig sabihin nito, pwedeng cathode to, pwedeng anode. So try natin to. Letter A, 2H plus 2 electron producing H2. So alamin mo muna, is this cathode, is this anode, no? So this is cathode, no? Reduction yan. So ano uli yung format kapag cathode? Ion, 'di ba? Metal ion, single line, metal, 'di ba? So ganun gagawin natin. Metal ion then metal, no? However, hydrogen yung gamit natin, so hindi to metal pero it will still follow the same format. So you have the hydrogen ion, single line, the hydrogen gas. Then again, kapag hydrogen ang pinag-uusapan, lalagyan mo ng catalyst sa dulo. Okay? Lagyan mo ng catalyst. Since this is reduction reaction, yung catalyst mo ay nasa right side. Pag yan ay oxidation excuse me. Pag yan ay oxidation reaction, nasa left side yung catalyst. So again, nasa left side kapag anode, nasa right side kapag cathode, no? So this time nasa dulong right, no? Kasi cathode to. So this is the notation for the cathode electrode. So let's try letter B. Alamin mo muna kung yan ay cathode or anode. So we have zinc producing zinc 2 plus and 2 electrons. So again, yung electron nasa product side, so this is oxidation or anode. Ano yung format sa anode? Metal, single line, metal ion. Okay, so ganun gagawin natin. So you have your metal, then followed by the metal ion. Okay, hindi mo na ipapakita yung electron. Ayan yung notation. So this is for the cathode. This is for the anode. Okay. Let's try number 2. Write the cell reaction for the voltaic cell. Tellurium, single line, tellurium plus, double line, tin 2 plus, single line, tin. Okay. So again, take note, itong double line sa gitna, that is the salt bridge, no? So, meaning yan yung nasa left, ito yung anode. On the right side, you have your cathode. Okay? So, anong gagawin nyo? How are you going to write the anode reaction? O yung single line, gawin mong arrow lang. So, that will be TL single line, TL plus. So, that's your anode reaction. And your cathode reaction will be Cathode reaction will be SN2 plus arrow SN. Okay. So again, yung single line, ko-convert nyo lang into arrow. Then you will have your half equations na. So if you want to balance that, madali na lang yan. Lagyan mo ng electron, then pagsamahin mo sila. Okay? So di ko na gagawin yan. Kaya na mag-balance yan. Let's try this one. Letter B. Zinc, solid. So zinc metal, single line, zinc 2 plus, double line, Fe3 plus, comma, Fe2 plus, single line, PT. Okay. So ano yung weird dito? Ano yung weird? Yung comma. Okay. So kapag comma, ibig sabihin yan, walang metal. Okay. So walang metal sa case na to sa right side, no? Walang metal sa sa cathode. Okay. Okay. So bakit comma, no? Okay, ganito kasi. Yung single line, ginagamit yan to separate phases, no? Kunwari, solid and aqueous, no? Or solid or ion, single line gamit natin. O kunwari, ion and gas, single line din gamit natin. Pero, kapag yan ay, kunwari, aqueous, no? Ion pati ion, yung magkatabi, comma yung gamit. Okay? So, again, kapag metal and ion, single line gamit. Kapag ion, gas, single line yung gamit. Pero kapag ion, tas ion, comma yung gamit, no? Okay. So, this is still boundary yan, no? Ano pa? Tignan nyo tong Fe3 plus pati Fe2 plus. Sa dulo nun may PT. Ibig sabihin nun may catalyst na kailangan dito. Siyempre, ions yan. So, again, yung platinum, hindi mo yan isasama kasi catalyst lang yan. Okay? So, yan. Paano natin kukunin yung half equations dito? Again, ito yung salt bridge. Huwag mo papansinin yan. Nasa left side yung anode, nasa right side yung cathode. Okay? So, paano mo kukunin yung half equation sa anode? Yung single line, gawin mong arrow. So, that will be zinc 2 plus. Yan yung anode mo. How about yung cathode? Wala tayong single line. Yung comma yung meron. Okay, yung comma, i-convert mo to arrow. Okay? So, yan. So, that will be Fe3 plus to Fe2 plus. Okay? Yung platinum, hindi sinasama yan sa equation, ha? Hindi sinasama yan sa equation. Catalyst yan eh. Let's have letter C. CD, single line, CD2 plus, double line, H plus, single line, H2, single line, PT. So again, this is your salt bridge. On the left side, you have your anode. You have your cathode on the right side. Again, PT, hindi yan kasama sa equation. So yung mga single line, gawin mong arrow. Okay? So your anode will be CD, arrow, CD2 plus. Your cathode will be H plus, right arrow, H2. Then, ibabalance mo na lang yan. Okay? To get the overall equation. Okay? So, that's how we represent voltaic cell, no? Using cell notations. Okay. So, ngayon, punta na tayo sa mismong application na itong topic na to, no? Paano mo malalaman kung gaano karaming kuryente yung mapoproduce mo, no? So, in order for you to identify yung dami ng kuryente na mapoproduce ng iyong cell, let's talk about standard cell potentials now. Okay. Ano natin malalaman yung overall cell potential, no? Meaning ng cell potential, yung voltage na kaya gawin ng iyong cell, no? So, in order for us to solve for the cell potential, gagawin lang natin is kukunin natin yung anode potential and yung cathode potential, no? So, we will use this equation. Okay. So, ito yung isang equation pero I don't suggest you to use this. Malilito kasi kayo no? So, wag nyo na gamitin yan. Okay. So, ito yung mas magandang equation. So, basically, ang gagawin natin is hahanapin natin yung ENOT tawag namin dyan, ENOT cell or the standard cell potential. Para ma-solve mo yan, that is the cell potential of the cathode minus the cell potential of the anode. Okay? So, saan po namin makikita yung values ng cell potential? No? May table. Okay, so on this table, nakalagay na dyan lahat ng cell potential natin. Okay? So, hanapin mo, sino yung cathode reaction? Okay, pag nakita mo, ito yung cathode reaction. No? Ito yung voltage na katumbas nun. So, yan yung maging E-cat, no? E-not cathode. Kunwari, hinahanap mo yung anode mo. Ito yung anode mo. So, ito yung iyong E-not anode. Okay? Tapos, pag susubtract mo yan, E-cat minus E-anode. Yan. So, yun na yung cell potential mo. Okay, so, yun yung voltage na makukuha mo from your cell. Okay. So, kuha tayong example here. No? So, consider natin this cell potential. So, that's zinc to zinc 2 plus, salt bridge copper to copper 2 plus. From the cell notation, we know that zinc is oxidized, so it is our anode. Okay. And copper is reduced, so it is our cathode. Okay. So, gagawin natin, hanapin nyo yung cell potential ng anode and ng cathode. Okay. Yun nandito sa SRP table. SRP tawag diyan ay standard reduction potential table. Ito ay naka-reduction formula. So ibig sabihin yung mga anode dito nakabaliktad. Okay? Nakabaliktad yung mga anode doon, pero hindi natin papansinin 'yon. Okay? Huwag niyo pansinin kung baliktad yung equation or not. Okay? So gagawin nyo is that hanapin nyo yung zinc 2 plus reaction dito. So, hanapin natin yung zinc, pati zinc 2 plus reaction. Regardless kung baliktad yan or hindi. No? So, ganun gagawin nyo. Hanapin nyo yung zinc 2 plus. Okay, so ito siya. So, yan yung zinc 2 plus. Nabalik ko pa yung highlight ko. Okay. So, mapapansin nyo dito sa SRP table, nakabaliktad yung zinc, pati zinc 2 plus, pero it doesn't matter. Okay. So, kunin mo yung niya, SRP values, no, or standard reduction potential value. Nakalagay dyan, negative 0.76. No? So, ibig sabihin yan, ang E-not anode will be negative 0.76. O yung cathode naman, copper 2 plus to copper. Hanapin mo yan dito sa table. Copper 2 plus to copper. Nakita ko na agad na. So, ito na yun. Ayan. So, copper 2 plus to copper, that is 0.34. Okay. So, our E cathode will be 0.34. So, ano gagawin mo? So, to solve for the cell value, okay, yung kuryente na mapoproduce ng iyong cell diagram, alamin mo kung gaano karaming kuryente mapoproduce dyan. Ano lang yan? That's E naught cell equals E cat minus E anode. Okay? So, again, E naught cell is equals to E cat minus E anode. Not. No. No. So that will be 0.34 minus negative 0.76, which is 1.10 volts. No? Ganyang kalaki yung kuryente na mapoproduce ng cell mo. So enough na yan to power a small LED bulb. No? Yun yung ginawa namin last year, 2019 pa. Hindi natin magawa ngayon. Nasa bahay tayo eh. Okay? So, ayan. Practice. Letter A. Determine the E-naught set of the following reactions. So we have CD to CD2 plus, double line H plus, H2. Okay? So hanapin mo yung anode, hanapin mo yung cathode. Obviously, ito yung iyong anode. Ito yung inyong cathode. Okay? Ayan. So hanapin mo yung E-naught anode. Okay, so CD2 plus. Hanapin mo yun dito sa SRP table. CD2 plus. Kita ko na. So CD2 plus is negative 0.40. Negative 0.40 volts ang anode. Ang cathode ay H plus H2. Hanapin mo yung H plus H2. Madali lang. Siya yung naka-red. Siya kasi yung standard, no? Lahat ng values sa kanya binase, no? So, siya yung 0. Okay, so, 0 volts yan. So, ngayon, alamin natin yung voltage ng cell natin. So, that will be E cell equals E naught cathode minus E naught anode. So that will be 0 volts minus negative 0.40 volts equals, it will be 0.40 volts positive. Okay. So kapag positive yung E cell mo, that is voltaic cell. Okay. So ibig sabihin yan, magbibigay yan ng kuryente. Voltaic cell yan. That is voltaic cell, and that means it is spontaneous. Spontaneous meaning tuloy-tuloy yung reaction. Magbibigay ng kuryente. Let's try yun nasa baba. Letter B, zinc to zinc 2 plus, double arrow, double line, Fe3 plus, Fe2 plus. Okay? So, syempre, ito yung iyong anode. Ito yung inyong cathode. So, yan. Hanapin nyo yung E naught ng anode. Zinc to zinc 2 plus. Hanapin natin sa table. Hanap sa table. Okay lang. Zinc 2 plus. Ito nakita ko na. Ayan. So, negative 0.76 yung zinc 2 plus. Okay. Negative 0.76 volts. So, yung Fe3 plus, Fe2 plus. Hanapin natin. Fe3 plus, Fe2 plus. Be careful ha. Kailangan Fe3 plus, Fe2 plus yung makita natin dito. So, ito, Fe3 plus, Fe2 plus. Ayan, so that is 0.77 volts positive. 3 plus, 2 plus. So, E naught cathode, 0.77 volts. So, to solve for the total voltage of the cell, that's E naught cathode minus E naught anode. Okay. That would be 0.77 minus negative 0.76 volts. Calcu ko na to Makakatamad mental eh. So the total voltage will be 1.53 volts. No? Okay. So since that is positive, yan ay voltaic and spontaneous yung reaction. Last one. Kayo na bahala sa iba, ha? Okay. So let me try this. Fe2 plus dichromate producing Fe3 plus chromate. Chromium 3 plus. Ganito. Diba, gagawin mo dyan, gagawin mong half equation, then ibabalance mo siya. Ito, shortcut ko na lang to ha. Shortcut ko. Tuturo ko sa inyo yung shortcut ko. Tumaas yung kanyang charge. So, ibig sabihin yan ay anode. Okay? Siya yung oxidation. Ganun na lang. Gamitin nyo yung concept ng oxidation numbers. So, kung yan ay anode, that means ito ay cathode. Work smart na. Kailangan isang tingin nyo pa lang maging familiar na kayo. Tumaas yung charge ng Fe. Ibig sabihin nun, losing electron. Yun ay oxidation or anode. Okay? Then yun natira, ito yun yung cathode. Okay? So, work smart para mabilis mag-solve. So, hanapin natin yung E naught anode, pati yung E naught cathode. So, hanapin natin yung Fe2 plus, Fe3 plus. Actually, na-solve na natin yung kanina. Andito ba yun? Ayun, 0.77 yun. Okay. Then, yung cathode, dichromate to chromium 3 plus. Hanapin na lang natin. Dichromate, chromium 3 plus. Okay, so ito yung dichromate, chromium 3 plus, 1.33. Okay, so positive 1.33. So that will be E naught cell equals E naught cathode minus E naught anode. Okay, so that will be 1.33 minus 0.77 volts. So that will be 0.56 volts. Na bumaba yung overall value. Okay. So still positive yan. So that is spontaneous and voltaic cell yan. Pag yan ay naging negative, yan ay electrolytic cell and non-spontaneous yan. Okay? So yan lang. So I think that will be all for today na lang, no? So syempre mabilis ko lang to na discuss, no? I expect na ulit-ulitin niyo yung video para mas lalo niyo ma-absorb, no? So sa Monday, we will talk about the thermodynamics of redox reaction, no? Pag-usapan natin yung thermodynamics niya and then yung concentration effect sa cell. And then tapusin na natin yung topic na to sa Monday. Okay? So that will be all, no? Again, pag nabilisan kayo masyado sa discussion ko, ulit-ulitin nyo na lang yung video, ha? Okay, so yeah. So any questions can be sent directly to me. Mag-message na lang kayo sa Facebook or sa email. Okay, so I'll see you again. Bye-bye.